Hello everyone, you're welcome to this channel once again. Today we have another question from the aerodynamic point of view. Now let's read through the following question. Consider a low-speed subsonic wind tunnel with 12/1 contraction ratio for the nozzle if the flow in the test section is at standard sea level with a velocity of 50 meters per second. Calculate the height difference in the U-tube mercury manometer with one side connected to the nozzle inlet and the other side to the test section. Once again, consider a low-speed subsonic wind tunnel with 12:1 contraction ratio for the nozzle if the flow in the test section is at standard sea level condition with a velocity of 50 meters per second. Calculate the height difference in the U-tube mercury manometer with one side connected to the nozzle inlet and the other side connected to the test section. Today, we have a subsonic wind tunnel issue to solve. Now let's assume we pull out all our parameters for this subsonic wind tunnel test connected with a manometer. Now we understand that from the question we're told that the test is under standard sea level. At standard sea level. Our density equals 1.225 kilogram per meter cube. Now, by using the equation for the variation of pressure under a manometer tube connected to the throat of the nozzle, you can deduce that the variation of the pressure P1 minus P2 equals the dynamic pressure equation, which is half rho v squared 2 to bracket of 1 minus the ratio of the throat A to A1 squared Now let us forget that A1 equals 12 and A2 equals 1. That is to say the wind tunnel is connected with a contraction ratio nozzle with the area 1 which equals 12 and the area 2 which equals 1. And we know that the sea level density is 1.225 kilogram per meter cube, and we have a area contraction, and we're also given the velocity at the section 2, which is 50 meters per second. Now, by slotting all the values into this particular equation, we can deduce that our pressure variation P1 minus P2 equals half rho v squared. What's our rho? 1.225. What's our velocity? 50 squared to bracket of 1 minus 1 over 12 that gives us 1527 Newton per meter squared. Now from here we can deduce that the variation of pressure, which is P1 minus P2, equals the weight multiplied by the variation of the height of the mercury and don't let us forget that the weight of mercury equals 1.36 10 to 4 kilogram per meter cube. From there we can deduce that the weight of the mercury equals 1.36 10 to 4 multiplied by the g, acceleration due to gravity, 9.81 meter per second square, which is 9.81, which gives us 1.34 10 raised to the power 5 Newton per meter squared. So therefore, the change in height, that is the height difference from the U-tube mercury manometer equation, becomes the variation in pressure over the calculated weight of the mercury. That gives us 1527 over 1.34 times 10 raised to the power 5. It gives us 0.01149 meter. So our calculated height difference of the U2 mercury manometer on the other side of the nozzle equals 0.01149 meter. Thank you for staying tuned.